pizza, paninis. Since our first day in programming, we always had that tradition of bringing food into this class. However, there's only 2 days after today remaining in order to pursue this tradition. Therefore, Vincent and I decided to bring food into this class once more. However, today, the choice of food is significant. In fact, you either have the choice between carrots or candies, a choice that everyone has to make every day. In fact, you have to decide between choosing the healthy food or choosing the food that you love. This struggle is brought to life in Food Battle. Food Battle, the most awaited game. Oh, this one doesn't work, but it's fine. The most awaited game of the year. In fact, everyone loves it, and now our job is to make you love it too. We can review some of the best critics. 10 out of 10 by IGN. Food Battle is already a success. Best game of the year. And the most important, better than Shin to you by Mr. Hugo.
So the content of the presentation, the slides are only an introduction to the presentation. So we can talk about what is Food Battle and why is this the most anticipated game of the year. And most of the presentation will be presented in the gameplay, where we'll show the menu, the intro, the help section where everything is described, the third level because it's like a merge of everything, the end and the credits.
And so, what is Food Battle? As explained, Food Battle is a clash between the vegetables and the candies, and this clash is represented in a tower defense game. So, as explained in the beginning of the semester, a tower defense game is a game where you place towers in order to prevent the enemies from passing to point A to point B. And therefore, there will be countless of waves of enemies trying to pass, and you have to defend yourself with towers that you can upgrade, that you have different types of towers, and it's an amazing thing.
Also, Food Battle is made with handmade design, except for the menu background, the end background, and something else. The music. So everything is handmade using Sprite, 2D pixel software. So for example, the defeat screen, all the units, like the onion or the jalapeno. There's also a radish, broccoli, and a Brussels sprout. For the towers, there's a nerd box, a cookie, and a popcorn bag, and also all the buttons or everything in the interface.
Alright, there's also homemade sound that me and Vincent did using, what was the...
Audacity.
Audacity, yeah.
Basic Microsoft software.
However, I don't think the sound will work because it didn't work for the beginning. Nope, well, the sound doesn't work. I can try just to unplug the HDMI and...
Or you can reenact.
It's hard for the music.
So this is the sound when the onion dies. Oops.
That's what I am talking about.
That is the sound of Patchy the King, which is a character that is going to be introduced in the introduction. And
Broccoli Daddy here to save money.
this is the sound of Brock, the Broccoli King, that needs to save his daughter from the hands of Patchy, the Candy King. So if you go back to the presentation,
So the game also features an awesome story filled with suspense and thrilling action. So like mentioned, it's two kingdoms in war, the vegetables and the candies. The broccoli is one of the vegetables, and Patchy, the Sour Patch Kid, for the candies. And in general, Patchy steals the daughter of Brock, and now he's angry and he wants to get her back. So the war is the game, and after there is a conclusion, but I don't want to spoil, so you'll see that later in the presentation.
Okay, so a preview of the many features of our game. So basically there are 3 levels. We didn't want to make too many levels because we didn't have time to make too many units, and since we wanted to be we wanted the game to always be interactive and fun to play and not get redundant and boring, we wanted to always in each level introduce units and new features. Also, there's 3 towers, 3 which have all different functions. Like mentioned, the nerd box is a fast shooting turret that has a long range. You also have the cookie tower that can ignore the armor, so it is really powerful against certain tanky units. And you also have the popcorn tower, which can target, which does an explosion, so it targets multiple enemies at a time. So it is good against the swarm of little enemies. You also have a help section, so basically if you are stuck in the game or you don't know how a certain command works, you can simply click on it and you're going to have a full description of how the game works, which is going to be demonstrated in the game later on. You also have an amazing interactive menu that you can modify the sound and the music, because maybe you'll see the sound can be annoying depending on your taste. And we have an amazing story that is featured throughout the game.
So why is this the most anticipated game of the year? Well, let me tell you some facts. It's a strategy game accessible to everyone. It's very easy to play, not very complicated gameplay, and also everything is explained step by step in the help section. Approximately 30 minutes of pleasure, enjoyment. I did it myself, Oliver did it, my parents, all love the game. It's made by us, so awesome people, you know. And the story, like I said, is intriguing and has the biggest plot twist of the history of video games. We're not ready for it. And also the best soundtrack if it works.
Yeah, I don't know if you're going to be able to feature it, or otherwise we're going to feature it in 2 times, like present the part of the menu and then present what is the sound in the menu, because
and all the music, because
the music is really important.
Very good.
Yeah, and the sound effects are a big part of our project, and we have to present it.
And this is what makes the game so good, all the merging of everything, the sounds, the gameplay, everything. Perfect.
So yeah, so the sound doesn't work, but I can try just to show you what the sound looks like in the menu. So then you can either choose between, yeah, I'm just gonna, you can reduce the sound if you want, or from the, yeah, I'm just gonna plug back the HAV, it's gonna be easier. But as you can see, there's from the beginning an awesome soundtrack, and then you have either the option to play. Okay. You either have the option to play or to modify the sound. So here you can modify the music, and here you can modify the sound effects. So when a unit dies or when the tower shoots, this is the bar that you want to modify. So then if you go back and click on the button play, we either have the option to create a new game or to continue, because we have a saving system, which is really important because it's a solo game. So if you have to go, if your parents call to go eat, then you can just go and exit the game, and when you come back you're going to be at the same level, so it's really nice. But now we're going to do a new game. So since there is no sound, basically there's a little soundtrack I can show you. So there's little suspense music to put you in the ambience and everything.
And this is the voice of Ollie, the daughter that is
yeah. And now I'm gonna narrate you the story. It is a sorry guys. It is a cold night in the Vegetables Kingdom. Being in war with the candy for 23 years now, Brock, the Broccoli King, is planning with his daughter Holly and his assistant Tom the Tomato to attack the kingdom of Patchy, the Candy King, to destroy them once and for all. However, Tom the Tomato is a spy for Patchy, and he warns the Candy King of the upcoming attack. In the middle of the night, Brock hears a strange scream coming from his daughter's room, and he decides to go check if everything's alright. But suddenly, He sees that Ollie is not in her bed anymore and remarks that the window is left open. Having a look outside, he sees an army of candies at the door of the castle and Patchy running away with his daughter in his arm. Furious, the vegetable king rings the alarm and deploys all of his unit to chase the candy king to get back Ollie.
So whenever you're ready, you can click on next.
The next button, and then the game starts. So as I did before, I'm just gonna unplug the HDMI cable so you can hear the music. So this is basically the soundtrack that is gonna be throughout the game. And then it goes a little bit it's a little bit more intense as it goes along, but basically this is it. So if you go back to the game, as you can see, this is the same image that was shown for how we describe the tower defense game. So there's the path that the enemies are going to walk through. There's an interface where you can choose between getting each turret. And here you have a description of every turret. So basically the node box is selected, so you have its damage, its cost, its range, and some important stats. You also have in the middle the current wave you're on and the timer until the next wave. Now it's at 0 because you must click on call wave in order to have the wave. So here we see the unit that comes, and we could place a tower to stop them, but we're not gonna showcase this level, or we will. And
Just the three first units.
yeah, and then we can
So I
pause.
can do the sounds if you want.
We can pause the game. So basically, you come to the help menu, and there's two things you can do. You can go on to how to play, which you can do, and then you get a full description of the game. So you get the goal of the game first, which is to not let the unit cross. You get the commands, so you can left click to select and right click to deselect units. And if you scroll down, you have a screenshot of the game and many important features of it, like explain the unit that comes, the button to call the waves, your money and your health point remaining. You have the time until the next wave and the buttons to select the tower and place it. And this is described here. You have a full description of the description, and that's pretty much it. So now if you go onto Encyclopedia, you can click on each unit and get the full description of it, which is pretty cool. And the same goes for the towers. So this description is basically a bit similar to the description that you see here when in the game, but you can access it anywhere. So now if we go on to continue, you have the full selection of level, because in order to present the game at its finest, we need to access the third level, which contains also the ending, which is pretty much essential. And so this is the last level, which is the hardest because it's a straight path, so the units, you have less time to kill the units because there's no like detour and everything. So Vincent is gonna place the...
So I played the game a few times, so I know the strategy.
Whoops.
Let me start. You didn't see that. So here you go. So now I'm calling the waves, so all the units are going to come, and it's like two paths, so it's randomly chosen whether it comes from up or down. And there's no sounds, but
yeah,
it's a bit sad.
Can you just put this on fast? Yeah, I mean,
you can understand that the sounds make the core of the game.
yeah. And just gonna do it.
I'm probably dead now. Wait a minute.
Okay, so yeah, so basically, whenever a unit crosses the path or when a wave ends, you have random sound that can appear in order to make the game more interactive. So then, one unit passed, so Vincent lost a life, And basically this is gonna go on until we reach the 10 waves. And without the sound, it's pretty boring. And so this is a really tanky unit. So Vincent should try to put a cookie tower in order to prevent them from passing, but Vincent bought, it said, a nerd box, so he doesn't have a lot of money in order to prevent them from passing.
It's gonna be a
waiting game, and I don't know if he's gonna be able to place it until the 2 unit passes.
So like you can see, it's very strategic. So if you place an earth box with onions, well, you're in trouble. Or the popcorn also works. So for killing the onions, you really need the cookie tower.
Yeah, and since the onions are really like slow, a new wave had time to come, and so there's the radish and the jalapeno that were able to come, but this is a bit helpful because it gave enough money for Vincent to place the cookie tower.
But I'm still in trouble.
Yeah. So we're gonna see if he can kill it. Oh yes. Okay.
Oh, wow.
And so the onion, whenever it goes to a certain threshold of HP, there's a certain sound. So we heard the dying sound during the presentation, but there's also 2 other sounds for the onion. So basically, whenever he's at 66% of his HP and he's at 22%. So when he loses a skin of when he loses a part of his skin,
so I'm gonna place a popcorn.
Oh, that's bad idea.
It's all good.
And now you can call the wave because you're gonna get extra money for calling the wave earlier, which is a bit strategic, but it's another part of the game which is interesting.
Also, you can click on the whatever turret you want, and you can sell it or upgrade it.
Yeah.
So the cost of the upgrade is shown here in the interface. Try not to die. And I can upgrade the cookie. It's gonna do more damage.
Yeah.
And
so
if
Vincent clicks on it, we can see that the damage increased from 14 to 21, and its range also increased. So it's really useful because the cookie at first doesn't have the range to attack the unit at the top, but now it does.
And it's the same thing for every turret.
Yeah.
So if I click on this one, well, the damage is gonna go up, and also for the range. And same thing for the popcorn.
And so here's the 8th wave. Yeah, without sound in it.
Because when the bus is gonna come, we have a special
there's a
music
special
that
music.
is intense and gets you in the action. But it's very sad that it doesn't have sound. So I'm gonna upgrade a nerd box. So you can see again 11 damage and more range also compared to this one. So you can choose whether you want to upgrade or place a new tower. It's probably better to place a new tower, but with time the upgrades become better than placing the towers.
And so this is the last wave before the boss wave. So it's a really big wave, but with the towers that Vincent has, should be okay to finish it. Huh? Wow. Oh.
No.
You're fine because each onion loses 5 HP when they pass. The radish loses 1, and the Brussels sprout I think it's 1 also or 2, and the jalapeno is 3. And so now there's only 2 units remaining. And we're gonna unplug the game in order to hear when the bus comes. Yeah.
Well, you're gonna see after, just to put you in the mood.
Yeah. For now, just put it in the top. So this is the sound that when the bus is the bus comes. And then an intense music comes in. So, in order to continue the gameplay,
Plug it back in.
So you can see Brock is the
Brock and King. So he's a really big and tanky unit, really hard to defeat. And I don't know if Vincent is going to be able to defeat because he doesn't have a lot of cookies, which are really important in order to defeat it. You can. So place no. Cookie mistakes because the cookie doesn't have enough range to target its real position, which is the left, right, top left corner. So the cookie doesn't do anything until it's upgraded. So this one will be able to target it. So sell all those towers and place cookies
whoa, guys.
on the ship. You gotta survive in order to see the. Results. So now he has enough. Okay, so now he should maybe be fine. Okay, so he has now a lot of money.
Because
he can place a lot of
I sold
keys.
the tower that was upgraded, so we get more money.
And now he should be fine in order to defeat the big broccoli. We hope so.
Oh, je vois, ils sont rentrés ça.
And
Nice.
So we want to have the sound. So this is when you win.
so when you win, you either have the choice to go to the next level, but in this case, since it's a third level, you can only go to you can only press next because there's the conclusion and the last narration, or go back to the menu if you want.
So we're gonna narrate the end to have the music and also the music for the credits.
So, after being defeated, Brock finally decides to surrender after 23 years of war and goes to Patchy's castle to give him his allegiance. However, when arriving in the throne room, Brock finds his daughter by the side of Patchy and see an engagement ring in the hand of Ollie. Confused, he finds out that Patchy did not kidnap his daughter. They were in love. After this discovery, Brock officially signed a treaty with a peace treaty with Patchy for his daughter and the two kingdoms. Lived peacefully since then.
So we chose this music because it's an happy ending.
Happy ending, and then
one is happy and one is dance, you know.
And then you can go next. And then you can see the suspense until one day because you don't know what's gonna happen next. Because maybe there's gonna be a second food battle.
Who knows? Maybe. So, and the end.
This is the end.
Yeah.
And then
You have the credits,
you're going
but new music.
no music,
No.
noise. And
So
this is
our
obviously-
sound guy didn't do his job, so music don't work.
But this is it.
Yeah, so everyone knows our creative music, I think.
We showcasted
Well,
a lot
I
of
can
time.
put it on Spotify.
You have 1 minute.
And you can just put it back in. And leave. And this is it for us. Thank you for listening.
Hi, today Charles and I will talk about our game that we created for our project, which is called Tank Arena. So, a little bit of action. I'm going to do an intro about what the story of our game and everything behind the idea. Then I'm going to explain every feature that we have in our game, so that when later on Charles we're going to talk about the algorithms and the design, you're going to know what he's talking about. Then the softwares and other tools that we use to complete our project. Then, as I mentioned, algorithms and design, followed by some difficulties and problems that we faced and how we overcame them. And we're going to finish things off with a demonstration of our game, and we're going to play little games for you. So, introduction, what's our game? We since the beginning of the year, we knew that we wanted to do a game because we're both gamers and it's things that we like to play. However, we didn't know what type of game to do. We decided to do an arena game because we really inspire ourselves from two games that we love to play. Charles and I really love the game Super Smash Bros, which is really similar to our game, except that instead of having tanks, we have characters, and it's a 2D game where characters fight each other to death. And we also mashed this up with Pocket Tanks, which is a game I played during all my math class in Sec 5. It's a turn-based game where two tanks have to aim at each other to deal damage. And by putting both of them together, we had the idea of our game, which is a 2D platformer where you move a tank around and you can pick up power-ups and shoot each other. You have to calculate really the angle of the trajectory that you're going to shoot at. So once you start playing the game, it looks something like this. Right. Now, everything is a little bit grayed, and you have a countdown. It starts from 3 and it goes all the way to 1. And when it hits 0, you can start to move and to play around. You're going to be able to jump, move, fire projectiles, and this is what a picture of the game will look like. So you have the two tanks. You can choose between 5 colors of tanks that are over here. And this is the basic layout of the game. These are the platforms on which you can jump. And these are power-ups that spawn at intervals of about 10 seconds and at random locations on the map. And I'll explain all of those in details in a bit. Now, I zoomed on the top because usually it's a lot smaller, so it doesn't take much place. But you can see the numbers of rounds remaining, the score, and a timer. Currently, this is the second round of 4, and the score is 1-0 for the blue tank. And once you hit the last round, there's going to display a screen that says who won, or if it's a tie, it's 2-2. Over here you have the health bar and the inventory. Every time you take damage, you lose 1 health, and it's going to constantly be displayed on the health bar. And the inventory looks like this when you don't have an item. And over there, an item is going to be displayed over it if you do pick up an item. If you pick up an item and you already have one in your inventory, the one that you have in your inventory will be removed and replaced by the new one. So you can only have one item at a time, so you better think ahead of what you want to do. So I'm going to show all the power-ups one by one. Now, what's important to think is that so this is the first one. It's the bounce power-up. So this was a normal shot, and instead the bounce power-up will bounce off the ground and gives you an extra range after you shoot. This is the basic shot, without much velocity, so the bounce is really small. If you shoot with more velocity, since we wanted to make it accurately in physics, it's going to bounce bigger if you have more velocity. It's important to note that if you want to have more velocity, you can hold down the fire button longer to shoot further and higher. Now the second power-up is right over here. It's a knockback power-up. And what it does is that when it hits the other tank, the tank is going to be knocked back and not able to control himself for like 0.5 seconds while he's being knocked back. Then we have a fire projectile that leaves a flame on the ground, and if a tank runs in the flame, he's going to get knocked back and take damage. One of the last power-ups that has a little video is the ice power-up. It freezes the other tank in place, and it can't move for a while, and after you can start to move again. The images are a bit clunky over here, but the frozen image really shows your tank in ice, and it's the correct color of your tank. So if you change color, the ice will also change. We have a damage power-up over here that instead of doing 1 damage, it does 2 damage to the enemy tank. There's not a video because there would be nothing to show. The vials are a random power-up. Once you use it, it changes your power-up in inventory for another random power-up. You also have a health kit that gives back on health. And the last animation over here shows what happens when you use a power up, and it shows the upgraded tank. So once you use this toolbox, your tank is going to get upgraded, look a lot bulkier. You're going to gain 1 armor. The armor is depicted right to the left of your health bar. So you see if you have armor or not, and you can only have 1 armor at a time. Whenever a tank's health reaches 0, there's a nice explosion animation that happens, and everything's get grayed out like at the beginning. This means that, once again, you can't move, jump, shoot, or interact with anything. You have this screen which says who is the winner, and gives you the option to return to the menu and play again. This is what happens once the number of rounds reaches 0. If there's more than 1 round remaining, it automatically goes to a counter that counts from the 3, and the game starts again. So if we go to the menu, it looks something like this. You can either play the game, change the settings, or change the controls. This is the initial page that you arrive on if you open the game. It's important to note that in every, no matter where you are, you have this option, this menu bar at the top. With this option, if you click on options, it's a shortcut. It's a drop-down menu that appears, and it's shortcuts to go to back to the menu, to settings, control, or to exit the game. If we look at the controls, here you can change the team's color. It's the 5 colors that I showed at the beginning. You can choose if you want to play against a computer, or if you want to play against another player. If it's red, it's against another player, and if it's green, it's against the computer. If it's green, changing the player 2's color will change the computer's color. You can change the game timer and the number of rounds. Those are the default settings of no game timer and no rounds. And over here you can change the map. There's a total of 5 maps, and every map brings something special to the game. This is the default map. There's nothing special to this one. The second one is the hell map. It looks something like this. It's a picture, you can't see it, but at the bottom there's lava. It's a GIF, and it moves, and it's nice. Instead of spawning on the floor, you will spawn on these platforms, because if you ever fall down on the lava, you instantly die. So it adds a lot of challenge to this map. The following map is the moon map. In this map, gravity is much lower. Therefore, when you jump, you're going to jump much higher. So this is the normal jump when you're on the moon. It's over here, because gravity is 6 instead of 9.81. It's not the accurate gravity of the moon, or else the tank would just flow off the screen and it wouldn't be interactive. Normally the jump distance is about the first platform, so it's about double the jump distance. Since there's less gravity, there's also less friction and traction, so your tanks are going to be a bit slower when moving around, and the projectiles are going to fall off less fast, so you can shoot further away with less velocity. Now the next map is the mountain map. I forgot to mention that projectiles only collide with the sides and the floor. Therefore, they don't collide with these platforms. These mountain maps add 3 rocks that do collide with the projectiles. So if you shoot, you can hide behind a rock to try to block the projectile. However, if you're hiding behind a rock, you can't shoot, because or else you would just stand behind a rock and shoot and be invincible, and it'd be boring. So this is this map that adds these rocks to protect yourself. I also forgot to mention that these aren't walls over here on the sides. If you go out of the screen on one side, you're going to reappear on the other. So that can also be a way to play. The last map is the winter map. Every platform is changed by snow, and therefore you're going to slide, and it's going to be slippery and harder to control. You can't really show it in a picture, but we're going to do a game in the demonstration on it later, and you're going to see what it is. Now the last feature that we added are the controls. You can change every controls that you have from the controls menu. You can change the player 1's control and player 2's control. These are the default ones. If you change something for something, if you change a control for something unavailable or that wouldn't work, it will say that it's unavailable. And if you change for something that already exists, like 3 things the same letter, that won't work, then it's going to say that it already exists. And you can't go out of the controls menu with something that's unavailable or already exists. Instead, it will change back to the last working setting so that whatever you do if you play a game, it's going to work. On to the tools and software that we use. The basic software that we used is NetBeans. That was our IED. It's a really nice IED, and I personally love it with the Dracula plugin, which makes it darker and doesn't hurt the eye when you're working late at nights. We did all our game for Windows because we wanted to do a game on computer, and games don't work on Mac because that's how it works. We also did Photoshop to change, edit everything about our images because a good software that works really well. We took all of our pictures from freepik.com so that there are no copyrights and we can use them freely. And lastly, if ever we had difficulties and the teacher wasn't there or something like that, we used Stack Overflow and our Java book as tools to help us figure out what we did wrong or how does certain constructors work in certain objects. Sean?
So at the start of the project, we identified the main issues that we would face to be the interactions between the tanks, the platforms, and the items, the encoding of the AI, and the calculation and the implementation of the trajectories of the projectiles. We had a general idea of how we would approach all of these issues, but we didn't know how we would code them concretely. However, before doing any of this, we had to start by designing our UI, the way we would switch between all the different screens, and our basic game loop. So essentially, the way our program works is that we have a main pane that sort of acts as the background of the whole program, that clears itself and adds other panes individually, depending on which buttons are pressed by the users. So, in other words, from the main menu, the user can use the 3 different buttons to access any screens in our game. So when the play or play again buttons are pressed, the Boolean game running is set to true, which enables the items to start spawning, the timer to start its countdown to 0, and it enables the user inputs previously chosen by the user in the controls pane, which enables the tank to move left and right, jump, and shoot. The only way that the game running is set to false is from returning to the menu from the options toolbar. Otherwise, it's set to false when the game ends, either when one of the tanks is destroyed or when the timer is 0. So the main game loop in our program is contained inside the 2 tank pane objects that are created at the start of each game. Basically, the tank pane class has a start animation method that creates a timeline that checks for user input every 5 milliseconds. If the keys responsible for moving horizontally are held down by the users, the booleans moving left and moving right are set to true, which will reposition the tank slightly to the left or to the right, depending on which key is used. Before doing so, however, the algorithm makes sure that the tank isn't jumping, falling, or being knocked back, which is the state represented by the boolean airborne. The falling and jumping animations work very similarly to the start animation in that they all create a 5 millisecond timeline. Basically, the tank will follow a trajectory given from the mechanics formula, and every time it moves, it will call the check coordinates method to see whether or not it's about to land on a platform. So inside the check coordinates method, we basically hard-coded all of the platform coordinates and distinguish between the 3 possible states that the tank can have with the integer floor. So basically, whenever the tank moves up or down, the algorithm checks if the tank is about to collide with the platform, and if the answer is yes, the floor is incremented or decremented, the animation is stopped, and the x and y coordinates are locked. This works fairly well in our program since it runs in linear time. However, if we had used a bigger map, we would have needed to use a different algorithm since even though it would have also run in linear time, it would have been just way too long to code, which is something that occurred to us later on in the project when we did the hitbox class. So we used the hitbox class to make the bullets hit the tanks and to make the tanks pick up the items on the ground. But we realized that we could have also used it to make platform hitboxes and check if they intersect with the tanks in movement, which would have been easier and more efficient. So the two of the first 3 issues that we had identified at the start of the project were pretty much all solved with the timelines and the hitboxes that we just mentioned. The only remaining issue was the AI. So basically, the AI tank class extends the Champlain class, and so inherits all of its basic abilities. At the start of the game, the super constructor from Champlain is called, and it places the AI on the map with a given player number and a color. The main difference comes right after, when the AI animation method is called. Essentially, instead of relying on user input, the AI animation method uses pre-implemented if statements that dictate if the AI is about to move, shoot, or jump. So for example, the way that our fire bullet method works in Champlain is that it creates a projectile with a given velocity that can increase as the button pressed responsible for shooting the projectile is held down. And it will create an animation that's similar to the one in jumping animation from the mechanics formula. Instead, in the AI, we calculated all the perfect velocities for all the different distances between the two tanks possible. And yeah, so the AI will use this tool to continue to up and down the other player, and will always try to match its fate by jumping or falling off a platform. Can you use the demonstration?
C'est bon. Alright, so we're going to do a demonstration of the game. How did you do to show on the second screen?
On the setting. Can drag and drop it there too.
That's been dragged.
Yes. You have 2 minutes.
Yep. Alright, so this is the basic format game that we can play. Basically, the two things spawn, and this is without the AI, just a player against another player.
And then once you die, you're going to be able to see the animation that the tank explodes, and then you can go back to the menu. And we're going to show last game in the winter map that I talked about earlier against a computer. So Charles is the yellow tank and this is the computer. So you can see you can see the computer, if Charles wasn't moving, had a perfect aim, and we coded the computer so that he wouldn't use a power-up that would give him armor or health if he already had all of his health for the armor, and he will automatically use any power-up that he has if he knows it.
That's it?
That's it.
Well, before we start, we would just like to praise the other teams that passed before us. You guys did a tremendous job, so let's give you guys a warm round of applause. As for our program, we chose to do a circuit simulator because, well, the market currently isn't there. The circuit simulators that exist right now aren't up to par, they're not really good. And we also chose to do this because Tryon is a big Tryon is a big Minecraft player and he likes to create things to show off to his friends.
So,
Alright.
so he's right. Technology is advancing at a rate, and the simulators, they just can't keep up. So we did the job of keeping up for them. So here's.
Without further ado, let's walk you through our program.
So we're just gonna listen to one loop of this amazing music. Let me just. This music is called Going Higher from bensound.com, and it's like the theme music of our thing because we need a theme music, right? So we have many options. As you can see, there's many buttons. Does everyone see the buttons? We actually have an options button, and on this we can crank the volume up so we can hear the beat.
I have exam.
Oh yeah. We can mute, but we're not gonna mute because it's so amazing. And we can choose the background of each cell in the simulator. You're gonna see it's made out of cells, square cells, and we can just change the color to like maybe blue. So it does like a shadow and it's really cool, but actually it's not, so we're just gonna leave it white, right? And you can even pick a custom color, and it has a lot of options, and you see it took us a lot of time to implement this, right? So let's see what the simulator can do, right? So you just click sandbox. So it looks like this originally until you open the toolbox and you can add all sorts of things. So you add things and then you can observe what happens in the circuit. So let's do a really simple circuit. You pick a AC voltage source, which is like a plug in the wall. You pick a capacitor, and you can pick a resistor. You can rotate using the shortcut keys. Then you can just draw a wire like this. And then you have a circuit. Now it doesn't do much, right? But if you look at what's happening inside, you see there's the charge, the current, and you can actually right-click and observe all of these values in a graph, like this. And you can observe multiple values in the same graph. So here you observe the voltage versus the current in the capacitor. And you see that they're like sort of related. Actually, the current, the voltage is the derivative of the current, but that's like, you don't need to know that, but it's just, you can see the values, right, in a graph. So, but to fully appreciate the power of this, you need to like look at some circuits. So here's something. So here's a circuit that converts AC current to DC current. So this is AC. This is the AC source, and you see it's AC because it changes direction. This is a diode which allows the current to pass only in one direction, and it's actually a light emitting diode because it emits light when there's current passing through it, and you see it because it goes lighter. And you see the green one is the DC current passing through it because it doesn't change color. So there's one thing. Here's another circuit that I made, and it's really bigger. So here's something that just counts how many times you open and close a switch, and it counts in binary because that's how computers work, right? So 1, 2, 3, 4, 5, 6. Now you're gonna say, well, a computer can do that, like counting in binary, right? So maybe I just did something, but it's just a circuit. It's just a circuit made from transistors, resistors, and switches. It's really just that. So that's like one thing you can do, and you see it just counts until it's 16 and then it goes back. Okay, so what's another interesting circuit? This is the last demo we're gonna do before we go on. Here's like a calculator. So what this does is it adds two numbers in binary. So this is the input and this is what it's equal. So what's two numbers between 1 and 15? Can someone give me two numbers?
6, 9.
6. Okay, that's good. So what's okay? What's 6 in binary? I think it's this, right? And what's 9 in binary? I believe it's this. What's 6 plus 9?
15.
What's 6 plus 9?
15.
15. Is this 15? So yeah, it adds two numbers in binary. So you can, this is like, you can test all sorts of circuits in this before you make them in real life. If you're a producer for some kind of circuit firm like Intel, right? So
Let's show off
yeah,
the
this
features
is what you have. So yeah, let's show the features.
of Sandbox. Yeah, let's go back and show. So if you open a toolbox, you'll see all the possible circuit elements we have implemented. So this is a voltage source or a battery. This is a intensity current source, so it boosts the current of a circuit. This is, as he said, AC voltage source. This is a resistor, as we all know. This is ground. The pencil is used to create the wire. This is a two-portal.
It's a switch.
Yeah, two-terminal switch. And this is a three-terminal switch. This is a capacitor. This is the inductor. This is a diode. This is a light-emitting diode, LED. This is a transistor. This is a
Transistor. It's two different types of
Okay.
transistor.
This is just
To select.
yeah, two tools to select
Yeah, like this.
the currents. And if you right-click on any element, say the resistor. Yeah, if you right-click on any element.
Yeah. Okay.
Yeah, see, you can go right-click. Okay, place it. Yeah, you can edit the properties of the circuit element. So right now you could set the resistance to 10 or whatever you need to fit your needs.
Yeah, and you can do this with anything, like here, right here. You can change the color. What's a really good color? What was the really good color that I liked? Purple. 200, right? It wasn't 200. It was
Okay, anyways.
300. Oh, I like this color. I like this color. Does everyone like this color? Wait.
Anyways, look, here at the top you have a few drop-down menus. So if you go into File,
Oh yeah.
into File you can create a new sandbox, a new circuit.
Yeah.
You can open a new one as well. You can save the one you're currently editing, and you can.
You just do File, Save, and yeah, it also took us a lot of time to implement this, right? Because
Yeah.
it's really difficult.
And then let's look at the edit drop-down menu.
Yeah, in Edit you just have like the properties, which is this, right? And you have cut, copy, paste, rotate, right? You can flip, but whatever. So this is like other features. This, you can set the simulation speed if you want. This is more advanced stuff. And the tool is just like draw. Draw is this, right? Move is just moving like this. And select is selecting. So you can just select this and delete because you don't need it, right? Oh, yo, let's just do this so it's purple, right? Do we like this color or what? Okay. So now you're gonna ask how we did all this. How does it know like where the current goes and all of this? Well, it's an algorithm, folks. It's an algorithm, and this algorithm is really like it's not that simple, but basically what it does is it takes some current variables, it finds them in the circuit. So if you have a wire, there's going to be a certain current through it. And it just puts all these variables in a matrix, and it uses Kirchhoff's voltage laws and current laws to create a matrix of all of these. And it just solves. And the matrices can get really big, but the computer does a good job at solving them. It solved them in the biggest circuit I showed you, it's about 10 milliseconds. It can solve it, and it does that repeatedly, so it's live, right? The circuit is live. So that's it for the algorithm. Now, we should maybe we should show you some other features of this, right? Oh yeah, we did a really cool effect, which is like a water effect. It took us a lot of time to implement. It's true.
All right, let's look at the challenge. So the challenge, unlike the sandbox, is where you put your knowledge to test. You would go in there and you have 12 problems, and you'll get a question and you'll have to solve the question using your physics knowledge. So if we click on the first level and we attempt it.
Let's try this, folks. Let's try this. So, oh yeah, you notice the windows moved like this. It took us a lot of time to implement this.
So here the question is, what is the equivalent resistance of the circuit? So if a kind soul could solve the circuit for us, it would be appreciated.
Who knows the answer to this?
Jacob is really good.
Jacob.
Okay, anyways.
You need to show the values.
Yeah.
Okay, this is 1, this is 3, this is 6, 12,
7.
Anyway,
7.
Yeah,
Let's see if our fellow genius here is correct. 7 ohms, right?
And this is the screen when you get the correct answer. There's a music also, but Tryon muted the sound effects, so...
I didn't mute it. It's just really a thing.
Muted the sound effects in options.
Can you hear the music?
No, it's a sound effect anyways.
Okay.
If you head back to challenge...
Yeah, you click on challenge, and...
the points you earned in that specific level will be displayed here. So as you can see, it's green. Green means that you've done well in the level. It means you got more than 300 points. If you get between 100 and 300 points, it would be yellow, and if you get less than that, it would be red. So you did a bad job. And the levels progressively get harder. Here, the second level, as you can see, it's only capacitors. We could attempt it, but yeah, sure.
It's really boring, right?
It's your average.
Second level. So if you want, you can do all the levels, and it turns out you can. And if you do the final level, which is which involves a transistor circuit, and it's really like complicated, you know. But what resistance should the base transistor have? The base transistor have for the collector current to be 5 amps. And you calculate this, you do all the appropriate calculations, and you find out that the answer is 180.
0.8.
Oh,
replay.
It's not true.
Replay.
I misdid my calculations, you understand. And you find out that it's 180.8 actually. And when you do the final level, you get a picture of none other than Albert Einstein, because you really have to be Albert Einstein to do this, okay? So then you go back to challenges and you see you did all the level, which is amazing, right?
Great. So let's talk about how we tested our.
You have 2 minutes.
Okay. Okay. Let's talk about the shortcomings of our code. For one thing, we don't like Go in challenges. We don't like that when we open a level. Any level, the two screens are. Two screens are one over the other.
Yeah.
For a new user, it can be quite confusing because when you get this question, you don't know what circuit we're talking about. So yeah, we don't like that.
There's also like some complications in the way we implemented certain elements of the circuit, like the diode, which is a PN junction. We didn't implement it quite the way it should be, but it's okay for beginner circuits. It's like a noble lie. It's a lie of society. Fellas, do you believe in society's lies? You don't believe, then you're not going to believe the lie that we implemented the PN junction correctly. But it's like a lie that we tell children. But that's okay, because it's like you don't always need that feature. What's other shortcomings of our team?
Well, we tested our code by asking our fellow students to test the code, and Santiago noticed that when we would open, say, options pane, if you were to click on options again, it would open another pane, so it would create infinitely many panes, and this is not something we want. So thanks to Santiago, we fixed a few bugs, and also to test our program's objectives, which were to entertain the user and to be a tool to learn. We used the Go. And what was your feedback to Go? What did you tell us?
It was really fun but hard.
Yes.
Yeah.
So, according to Hugo's feedback, we achieved our objectives, which were again to entertain and to teach users about circuits.
Are there any questions, fellas?
Good.
No questions. Okay.
Thank you.
Thank you very much.
What's going on, man?
Man, like, I have this girl that I really like, but I just don't know if she feels the same way about me. And like, I want to ask her out on a date, but I don't want to get rejected, you know?
Man, I know the feeling. Have you tried Is She Into You?
What? Is she into you? Really? Oh shit. I'll go try it right now. I'll go download it right now. 1 second.
Yeah, it's amazing. We'll see.
Alright. Oh, it's already downloaded. Okay. Is she into you? Okay. So, get conclusion. Let's see. Alexa. It says she's into me.
Bro!
She's into me. Oh my gosh, so I really should text her.
Yeah, you should.
If she wants to go out on a date, right?
Yeah.
I'll do that right now. Okay, so, hey, Alexa, do you want to go out on a date with me? All right, it's sent. Oh, I received it. Yes. Oh my gosh. Okay. Man, I really hope she said yes.
I hope so.
She said sure with a smiley face.
Bro!
Oh my god, this is the best application ever!
It is. Well, you may be laughing now, but this is what Is She Into You is all about.
This is what Is She Into You can do for you.
So, Is She Into You is the first man-made application that can predict the love potential between a man and a woman based only on their text conversation using a unique and brand new algorithm. As you know, technologies have changed the way we interact with each other. We can now shop directly from our home. We have thousands of friends on Facebook, apps that we don't even know. A lot of things like that. Most importantly, we can now date women directly from our home. The opportunities are infinite. We have a lot of choice. You can see their pictures, you can choose which one you like the most. However, you need to take those opportunities. And the problem is simple. Men don't understand women. It's simple as this. What I mean by that is that men think differently than women, and they don't get the signals that women send in their text conversation. Today, on May 9, 2018, me, Hugo Latourelle-Vigeant, and my colleague, Johan Catalin-Hirschaba, presents the solution. An application that can decode women's feelings through texting only. Now you may be asking, how would you do this? Well, we know, okay? The algorithm behind Is She Into You was developed after exhaustive studies at both Champlain Regional College and Internet. We asked to a lot of girls, like, what are the hints that you let in your conversation when you like a guy? And we came up with a list of features that we could analyze to make a precise and accurate algorithm. I'll just name a few here because we analyze so much things that I cannot even put them all on the screen. First, we analyze the number of emojis that she sends you. It's a good sign. Repetitions of letter, I'll say it again because it's the famous example. Hey, this is a good sign if there is multiple Y's in A. Laughing, my friend, is a savior. If she laughs, you're good, you're in business. The number of times she initiates the conversation, if you're not like her dad or her mom, you want her to also talk to you sometimes, because if she does not, well, you're not going right. Punctuation, things like question marks or exclamation marks. The length of text, well, this is not always good, but if she takes the time to write a long message and to send it to you, well, it's good, right? You take part of her time. Many aspects of time, for example, the average answering time between two messages, the time between two conversations, and the number of messages, because we cannot analyze a conversation with only two messages. We will now do a demonstration of how Is She Into You works. So,
So buckle your seatbelts along, fellas, and prepare to be blown away 0 to 100 real quick.
Okay. So, let's say you're feeling lonely and you want this to change. I'm gonna show you what you need to do. First, you need to go on Google Play. Basic Google Play, no big deal. And you need to search for Is She Into You. First thing that comes up, Is She Into You, best app ever. You can install it in only like seconds. It doesn't take a lot of time. And I would just want to take this occasion to show that even Vincent Baudouin wrote that, wow, it is amazing. So yes, I'll just use my... You see, very quick. Oh. Well, you don't see, but it is. It is. everything's fine. Okay, when you open the app for the first time, you have the license agreement. If you look, you cannot do anything. Like if I tap anywhere, nothing works, you have to agree because we don't want to sue anybody here. Once you agree, you also have to allow Ishin to you to access both your contacts and your messages because... wait a minute. Oh, it works, certainly. Okay. It's just like... Wait. Okay. And now you see you have a beautiful and simple interface with the name of our application, the logo, 2 buttons. Now, I know you're thinking, why is there smoke in the background? Well, fellas, I have an explanation. Fire has been associated with love by many popular applications. Noise. Such as Tinder is their logo, Snapchat is the icon for streets, many more, I think. So, the same way smoke always comes with fire, Ishin to you should always come with love and relationship. See, there's a clear link. So here you have 2 buttons. If you click the rate this app button, you can just like it redirect you to the Google Play Store so you can put 5 stars, and I invite you to do so. But right, you didn't open the application just for this, so you're gonna click let's find out. It will come up.
Let's find out.
1 second.
No man. Let's look at it.
Oh, it's doing something.
It is.
Oh, okay. So basically now we have to select a conversation to analyze. As you can see here, we have a list of conversations which are implemented in your SMS conversations already. And it is also scrollable if Hugo can make a demonstration. Oh. Scrollable if you have multiple conversations that don't fit into.
It goes well on my cell phone. None of this, but it goes well.
That don't fit into the whole screen. So we also, our conversations are arranged in order of the last message you received from someone or that you sent from someone. And here we have the name for the user to identify the person he wants to talk to. The last message is sent, and also the time. If it was sent today, it will just give you the time, well, the time in hours. And if it was sent on another day, it will give you the date. And we also have a circle with our logo inside. Here it is with our logo inside because the contact does not have a photo administered to it. So we replaced the photo with our logo. And over here, if you do have a contact photo, well, we put the contact photo. So this makes it very easy for the user to identify what conversation he wants to select. And now, let's press on a conversation.
Alexa. It will show.
It will show eventually. One more second. I think there are too many things open on Hugo's computer, and this takes up a bit too much memory, maybe.
Je peux essayer d'arriver. Wait a second.
Local recipients.
Just put this way. No, you open it just to see. Okay. Oh, thanks. Okay. So this is the result activity. This is where the fun begins. Now you can see you have two graphs. The first is both scrollable and scalable. This is amazing, as you can see. You can see the conversation as a whole, like the evolution of the conversation, or you can zoom in particular time. I don't know if this is correct to see, for example, oh, there is a really big point. You can tap on the data point to see the date. For example, this was on April 15, 2018, and you had 472 points. And you can, like, as I said, scroll, scale. Yeah, like I said.
We also have the limit.
Yeah. The other graph is points by category. The name says it, it's the points by category. Such as, so you can see, for example, how many emojis she sent you. Alexa, for example, sent me 1,038 emojis. She did 57 repetitions of letters, 31 laughing, etc., etc. And if you missed something that I said and you don't know what to do, well, we got your back. We even did like a question mark on the right top corner. You just click on it. It shows you everything you need to know. It's amazing. Thank you very much.
Very user-friendly.
Okay. No, it's not finished. I switched it. But like, you didn't come this far only to look at the graph, right? You want to know the result.
Yes. So you want to see the conclusion. Now here we have the see the result button. And we also have the logo at the bottom of the screen. So if Hugo will make the honors to click, wow, an animation happens and the logo expands out of the screen and takes place the conclusion of the conversation. So here you have the name of the person is ... into you, and the conclusion, which is into you, not into you, probably into you. There are multiple conclusions, and these are based on the number of points that you already have in a certain conversation. So basically we have an interval of points, and if you're in that range, well, it will display the message within that range. This also takes place for the hint, and here it's written time to take it to the next level. And to make things very spicy and original, we made it so that the hint changes almost every time you click the conversation. Well, you click the see the results button. So even if you're in that range of points. So if Hugo will do the honors to click again.
Okay. No rush. Oh,
now it's written she is definitely in love.
She is.
And, well, that is it for the demonstration.
Oh yeah, and by clicking anywhere on the screen, you just like come back to the original screen so you can continue to look at the graphs and why she is or she is not.
You can also use the left arrow here.
Okay. Can I?
You have 2 minutes.
2 minutes.
And now let's talk a bit about the features. So it's a downloadable Android application that is available on Google Store for free. And we know that conversations mostly happen on cell phones, so basically we made this application specifically for cell phones. It is directly compatible with SMS because we know that love-related conversations mostly happen by SMS messaging, so it becomes very accessible to the user. We have the capability of analyzing any everyday conversations. So basically, if the person uses slang terms in a conversation, well, we will not only cope with those slang terms, but we will include them in in the calculation of our algorithm, like hey or emojis. We have the exemplary intuitive interface, which really helps the user make his way around the application. The scrollable and scalable graphical illustrations help the user have an idea of the evolution of the conversation, and as well he can see the most dominant traits of the conversation. We have the straightforward conclusions as you saw in the demonstrations, and no internet connection is required, so you can be anywhere in the world and you still have access to the shit. Even with. And for the specs, you can download it from Android 6.0, version 6.0. It is only 9.25 megabytes, so it won't take place at all on your cell phone. It is E-rated, so everyone can download it. And the best part, of course, it's free.
Amazing, right? This I will do pass quickly because we don't have time. Privacy is very important for us, by the way.
Yes. And for the numbers, it is unanimously rated with 5 stars, and it has several positive reviews, which will have examples, and it is downloaded internationally. So more than one continent has downloaded our application. Now, for the example 1, very good. I mean, it's really that simple. As simple as our intuitive interface, it's very good throughout the whole program issuing to you. Very good to me, so many things.
Well, now I want to just finish quickly this presentation with a comment that is really meaningful and wraps up what Ishin2U is about. So it's talking about Ishin2U, but this is beyond our comprehension. It's so magnificent, it's so greatness, it's so goddamn freakingly, awesomely, scientifically, extremely, artistically, critically, legendarily, deeply, traditionally, modernly, presently, grammatically phenomenon that for the first time in the history of white, black, Asian, Indian, Christian, Muslim, LGBT, Republic, democracy, communist, anarchy, monarchy, football, soccer, Apple, Samsung, PlayStation, Xbox, relativity, quantum mechanics, mankind, woman species, Mayweather in a book, that finally united all of us together. Thank you.
Thank you.
Alright, so hello folks. Today we're going to be talking about the platformer me and Min made. So the name is Upside Down, as you can see, and will be designed pretty much from the top bottom down using the software that we'll talk about soon. So, why we made a game? As you all probably know, we're both gamers. We enjoy playing games a lot. In our youth, we played a lot of platformers as well. I know Min had a few consoles back in the day, and he felt it like it was time to give a tribute back to those good old big games that got us started into this. And also, it was something that we thought would be a bit of a challenge. It's like it touches a lot of fields that we see, like programming, maths, and yeah. We also want to try and use an engine, which is why we chose to use libjigx to see how game development with that would work out instead of just using the swing components or jaw effect components. So, yeah, and it's something that matters a lot today because gaming is something that is widespread, so it has a lot of importance in today's society.
We want to bring happiness into the world, and we want people to enjoy our game a lot. So we made it challenging, but also very fun.
So why play our game? So as we said, it really did inspire us from classical platformers. You know, you see a lot of games that are released, but they're not that great. I don't know, the people spend too much time on the visuals, not enough on gameplay. Plus, we try to reach the perfect balance in that. So that's why it's simple and straightforward gameplay. As Min said, it's mechanically challenging and mentally challenging. So you both have to be good at platforming, and as well, you have to think sometimes to figure out the clues and try and make your way out of each level. And most importantly, it looks great. We did all the art ourselves, and yeah.
So what's the actual game? So the game is a platformer where you're this character who's trying to escape this science laboratory, and basically we have 6 levels, and each one of them is some kind of puzzle or some kind of game like level that tests your mechanics, and basically you have to get to the door at the end of the level, and you'll see.
Yeah, we also created a story for it, but unfortunately, due to a lack of time, we weren't able to implement the cutscenes we wanted. But at some time, we had to make the choice between making the game complete or making the game with cutscenes. And at the end, the story, though it's important to us, we really wanted to finish the game itself first, so we give that priority during that. And also, the reason we called it Upside Down was because that's the initial mechanic we both decided we wanted to put in the game. And it's really what really tied the whole project together in a way, and then what made us try to figure out.
The mechanic is the gravity change. So there's a block.
We'll explain it later though, we have no slide. So. Alright, so yeah. So, objectives-wise, this is what we said we were going to implement, so mechanics, so you can explain it there.
Okay, so yeah, the mechanics. So the main mechanic, the main thing that really makes our game different from all the others is the gravity block. And if you're a player and you go on the gravity block and you press the down key, the gravity switches and you go on top, and the whole dynamic of the game changes. It's great. And there's also jump mechanic, sprint mechanic, there's a stamina bar, so if you sprint for too long, like all the controls are, you can't jump anymore, you can't sprint.
You can walk, you can walk.
You can walk, yeah, you can walk. There's also wall jumps that's implemented, and there's a box that you can use to put on pressure plates and disable lasers. There's also lasers that kill you, spikes that kill you, all that.
And also the box, you can grab it, and there's the one where there's multiple boxes, so you can grab those two and it won't interfere with the game. You just grab it normally, like you would in a level that only has one box. Then there's also the sprites, which were, well,
yeah, so we made the sprites using a sprite as well, and they're all homemade, made straight from the heart, and that's pretty much it.
So physics implementation, we had to use our knowledge of vectors and well, gravity, of course. Also forces, since we applied either velocities or impulse to the bodies to make them move. Then the boss battle, which was one of our objectives that unfortunately we didn't have time to make, though we do want to add them in the future, but probably like DLC, so they'll come later on, like all good games. And yeah, there's also a progression which we didn't manage to implement, so your progress will be kept in-game while you're playing. So things we want to add in the future, so this game, it's very good, it's very nice, but we feel like there's a lot more that can go into it, and this is what we want to do later. So cutscenes, as we said, just to explain the story itself. At tutorial level, to teach the players the controls, because we feel like sometimes it's hard to learn during the game how everything works. So pretty much a simple level to do that would be very nice. Additional songs, because right now we only have one track that keeps playing on and on. It might get tiring after a while. So.
No, I think that's good, because we want the players to be mad.
Yeah, so it's made for that. And then textures. Because right now, pressure plate, we added a lot of functionality to it, so sometimes it works as a sensor, sometimes as a button, but maybe adding more textures to it would make it more clear on what the functionality is in each level. So as we said, that's the tools we use.
So we used A-Sprite to make the sprites. We used the GDX texture packer to make all the textures work with libGDX, because the libGDX textures are not PNG, they're actually Atlas, which is something else. We used Audacity to make some of the sounds. We used libGDX, like I said, and we used NetBeans because it's the best IP.
Yeah, I need a Gradle to run it, of course. So, yeah. So project design, the main problem we had to face was finding a way to actually implement the gravity reversal. We had a few ideas at first on how to do it, just applying a counter vector to the gravity vector. We tried that, did not work that well. So it was something to do with the refresh time of each of the updates in the system. So sometimes it didn't apply the gravity vector at the same time that it applied the other vector, so there were like variations of decimals. To make it more consistent, since a platformer should be something that you can predict and always does the same thing, what we did was find a different function that instead of just adding a vector, it modified the value of the gravity vector. So let's say you take the gravity vector, then you scale it towards the negative, you basically reverse it. So what you do is in a way, a vector multiplication. So that's how we managed to fix that problem and get it to work. So yeah. Code structure. As you can see, it's pretty self-explanatory. You can see all the classes here, all the lines. If you have a good 2 minutes, you should get it all down. It's very, very simple. We'll go through all this. So, you guys got it? No? Good. We'll probably try to explain it in depth, but it's really not that hard. It's just that everything's divided into packages, and us, instead of using inheritance, we tend to use composition. So classes are instantiated, and they use each other as needed. But that's why there's a lot of links between all classes, because sometimes you need a class, but it's not necessarily the same type. So that's why it looks messy. And yeah. So, we'll go quickly over this. So the first package is the prelab package. In it are just classes to control. So prelab is just like level selection. Contact listener just listens for contacts. We use it later on. App preferences just store the preferences. As you can see, there's booleans and then float values. So very much you can get the preferences there. And yeah, it stores the values. Then you have a body factory and a load factory, which use helper classes. They create either world bodies or bodies in the game. So. And then you have components. Components just store data for all characters and objects. Systems are used to get entities that have components. So as you can see, there are a lot of them. And here we just have a sample system just to get you to understand a bit more how it works. So in player control system, you have pretty much just, it takes the input from the keyboard, which is why it takes the keyboard controller. And then inside it, you'll have different, it has the process entity method, which will just take the player and analyze what inputs you gave and then control the character according to that. So that's just a sample of the system. There's a lot of other systems we use, like animation systems and rendering systems, so just to display and stuff like that. So yeah, that's how that works. Then we have all the screens that we created. The screen is just like main menu screen or like gameplay screens.
That's what is displayed on the screen.
Yeah, exactly. So pretty much that. Sample screen as well, but we'll go over that quickly since we don't have a lot of time. And then just the asset manager, which manages all the images. As Min said, it is an Atlas, how images are stored, which is more efficient with an asset manager, but I mean, yeah, it's why it's there. Then let's keep on going. So, do you want to do it or go ahead? Go ahead. So for the methods of evaluation, we said that as we said before, the platformer had to be consistent. So we checked 3 things: the controls, the physics, and the hitboxes for collisions. For testing the controls, we pretty much just checked that when you hit an arrow, it pretty much reacted instantly. Because if it didn't, then the delay would probably mess up your gameplay. And also that the conditions are reasonable. For example, for wall jump, at first the window that we had given was a bit too short, so a player could hit the wall, try and make the wall jump, but then it would not always do it since he had only a fraction of a second to react. So yeah, we also adjusted the windows accordingly to make the controls feel more natural. Then from that, we also tested the physics.
Yeah. So yeah, we just tested if it works. You can tell if gravity works or not. It's easy to tell. And the wall jump, if it responds well or not. Because sometimes, back in the earlier times when we tested. Sometimes the wall jump just didn't work, and other times it did, so we just had to see if it works.
Yeah, and the final point is just to make all that predictable. That's why the changes were made. So yeah. And then hitboxes, we use system.out.print to check which objects collided. We have a type component that stores the type, and that pretty much tells us what object hit what object. So yeah, all right, and yeah. So pros and cons.
Okay, so basically, the way our code is made, it's really easy once everything's done to make a new level. But the hard part is actually making everything, and that it was not very fun to make. I'll tell you that for sure. It was hard. It was hard because when we checked the libgdx tutorial, we were introduced to entities and Ashley, which is a way to make the game, and it was just very complicated. And we later learned that there were easier ways, so it was that's the con, I guess.
Then on the pros, then it's like once the base code is set up, then there's a lot of potential to keep building on more features. I guess that'd be the plus. But it's just setting up the base code that's pretty complicated. So here are the controls for the game. If you want to, you can make a rundown.
Okay, so jump up, walk left, walk right. Interact is down, wall jump. So when you wall jump, you have to be pressing up and left if you were on the right wall, and up and right if you're on the left wall. And shift is sprint, that's it.
Yeah, and as mentioned before, no stamina means you can no longer run or jump. So conclusion.
Doesn't matter.
Alright, it's pretty great. We're gonna show you. We're pretty proud of what we made, and I think we can go on to the game demo. So we can also have a volunteer from the audience later on to play the game, but for now we'll just start by running it. So we have a loading screen, as you can see here. That's one of the screens we have. We have music as well. You can go to the preference screen and change the values. Let's say we want more volume just to test it. Volume goes up. You can also mute it. And you can also change the sounds and all that, just to show you it works. Then we'll leave this. How about this? So you can also go to select level if you just want to run it to a specific level since you've already played. If not, what you can do is go to story mode and then try and do one level at a time. So you can see here I'm tracking the down arrow, but I can't go in. Since only level 1 is unlocked in the first gameplay. So just to quickly explain the level, the goal here would be to get the box that's over there, put it on the pressure plate that's there, which will deactivate this laser so you can get to the end.
Yeah, that's the door to get to. So, and you have to find a way to get to the end using the mechanics that you have. And you see here there's a gravity block, there's another one there, so you have to use your head to get that and get to the end.
So I'll do this as a sample, but then from there on we'll ask other people to run the game. Oh. You saw nothing.
Oh yeah, and there's sound effects for all the
deaths, since you die often, so...
Oh!
Oh, come on. And as you can see, when you finish the level, the next one becomes unlocked, but the rest stay locked, so you can't go in.
So you have 2 minutes.
2 minutes? Okay, who wants to play the game?
Any volunteer from the audience? Young wants to do it? Do you want to go level 2 or
do a harder level, do like level 5. Do level 5.
Level 5? Alright, let's try 5, let's try 5. Alright, try to figure it out. You guys can help him if you see how it works.
Okay, I see. Show yourself.
There's a logic to it, but
press down to grab it if you want.
Up?
But it doesn't work. So you have to find out how.
Wait, I'll play. Put the box on there.
Yeah, this one's like a puzzle, so it's harder. But basically, if you want to tell him what to do, put the box on the thing.
So pretty much, the thing is, this pressure plate here is a timer. So
Yeah,
give
this
you a
one
window
is
of
a
3
timer
seconds
here.
to go grab the box once you hit this one.
Oh, okay. Okay, I see.
Yeah? Oh. You can press R to restart if not, it will be faster. So when you hit it, yeah, there we go, see?
But there's like a certain time, so you have to be fast. You have to be good.
Okay, Santi. Alright, I'll show you how it works. But as you can see, it's mental and at the same time it's mechanical.
Wow, cool.
So also, we'll show you a wall jump if I can succeed it here.
Oh!
And then this one you have to realize that there's 2 pressure plates. So using this one, oh shit. Okay, so using that, I'll show you the solution real fast. If I can manage to speedrun this. Ah. There we go. Ah. And as you can see, the last part is hard, but yeah. Pretty much when you get to the end, you'll finish the level and then you continue like that. So, yeah.
So hello everybody. So if you don't remember, we presented 2 months ago, something like that. We're doing a replica of a game that exists already. It's called TIS 100 for Tessellated Intelligent System. And it's a game developed, I don't remember by which company? Netronics? Zachtronics, that does also Infinifactory, if you have heard of that game. Anyway, so it's a puzzle game about programming, and instead of having one solution, for example, like Santiago's game, which is really complex, but still, we give the players the freedom of finding their own solution by creating an environment of which they can program whatever they want to achieve a solution.
So, quick side note before we start with the presentation. Typically, the game has a level check system, such that level 8 and 9 are typically locked until you complete a certain number of levels. But for the sake of this presentation, I have edited the stats file to say that all levels are unlocked, so you can present these without completing all the other levels. So, let's first talk. Did you talk about the goal? Game?
The goal of the game is to complete every level, which is like the little puzzles. Those are the ones that
Yeah. So let me first show you level 0.
And yeah, the first game is really complex. Even the first level is really difficult. So we tried to make it actually feasible for people that don't know a lot about programming. So that's why we have a lot of we have a few really easy levels to show how it works.
Right, so first let me talk about the graphics that are done here. So firstly, as you may see, the graphics seem very well done. That's because we didn't do them. I actually ripped them from the original game and edited them to my own needs. This is a remake, of course. I'm not claiming this is my own creation.
We still did all of the engine by ourselves. Right. The original game is done in Unity. We all redone it in Java.
So firstly, you see this in terms of graphic. It's all a bunch of background images that are stretched to the screen with a bunch of different Java elements inside to add functionality. You may not see here because it might actually be hidden by the table. But around this corner, there are hotkeys options, which are both F1 and Escape, which basically implement certain key features. For example, the ability to say go back to the main menu, erase, say what you've done so far if you think you've done basically nothing important, or view the manual, which I can just show you real quick, which basically opens a PDF of a quick guide, if you wish, for the game.
The game is pretty complex and can get very overwhelming, so that's why we did, and the original game did also a manual, because you get inside and you don't really know what to do, and you have to check the functions to know what to do.
So following that, there's also the F1 key, which is a quick reference set of all the operators you can use inside of a program. So let me run it just for you, while Jeremy will talk to you about the tick system, the way this whole thing operates.
So quickly, there's like the 12 nodes, which you can write code inside it. And then, well, when you start it, it decodes like what you've written and it activates that. So, and it works as a tick, so like it does a tick every, I don't know, we changed it, like 500?
0.5, I think, for
0.5 second. So it does a tick each 0.5 second, and it like does like what's in each node. So the empty node does nothing. And this easy level is get a value up, and it asks for the same value down there. So you just move the value across the different nodes and like answer it.
So two more things I want to demonstrate before we get back to another level. Firstly, the way the tables work. The way the tables work is you see you have the inputs right here and the expected outputs right here. So basically what it does is that whenever an output is received here, it displays it in the output table here, and if it's not the right value, it's going to give you an error. So to demonstrate this, I'm also going to present the way how the whole program works. So I'd like to ask you for a simple modification to the value that you want to add to make the program not run but still work. Say for example, negating the value or adding something. Anybody has any suggestions? Sure. I'll negate the value before we reach it.
So like the player can like the player writes the code like this, and if you write something wrong, like it shows that it's wrong or something.
So now what will happen is that the value will be received and encrypted and stored in this node. Neg basically negates this value, and then I send it out to the right node, and then I remove it so I can just do the single operation again to the next value I receive.
Obviously, when it like reaches the end, it goes back up.
So, maybe too loud. So whenever you receive a wrong output, it displays a sound and displays on the table, and it doesn't go to the second part of the test, which is the random test, whenever it receives a wrong output.
And yeah, we can show that like level 1 maybe.
Yes. Okay, so as you may have seen, I've done some modification to level 0. So let me show you. So basically the way our system works, it works on a save system. And so you've seen I've modified the save 1 of level 0 such that once I return to it, it'll save everything back to what it was. The way we do this is that every time we exit a level, we activate we basically read through every single text code which compose a level and basically set it inside of a text file. And so the way you can access all these text files if you wish is to open the save directory, which shows you exactly what each save file contains. Right, so with the fact that you can open the save directory directly, you can, if you want, directly make a copy of a certain level to another one. Or say you're stuck on a level and you want a solution, you can just find one online and just replace a certain save file you have.
The original game had that.
Yes.
It's like really challenging, so sometimes you have to, like you may want to go on internet and find the actual answer so you can continue forward. Like we only blocked level 8 and 9, but I think we got one level. So
right.
It's more difficult.
So we're going to run through level 1 to the entirety to talk to you a bit more about the level check system.
So it's the level 1 is simply double the value. So for example, it's almost all the move functions, but if not, you have I move it to the ACC. So each node has 2 storage values, which is the ACC and the back. So the ACC is just like a normal variable that you can add and subtract and move around and negate and do stuff like that. And the back value can only write and read from it. You can't negate it or add something to it or stuff like that. So so fast.
Alright, so I'll go quickly. So I actually didn't show you the random test. So currently what we're running is a table of values that is actually hard-coded inside of our code. But there are two sections to each level, which is the hard-coded section of inputs and the randomly selected series of inputs. So if it follows, it goes through quickly. It'll go to another section of inputs where you'll notice that it puts out another series of inputs. These inputs are randomly generated. There's an algorithm that we've made, which depending on which level you have, it changes which value can and cannot give you.
So it creates random values for every level. We created a different algorithm to get the random values. This one is obviously really simple.
So whenever you complete a level, you can do two things. You can either continue editing the segment that you completed. Say, for example, you find that your algorithm is not efficient enough and you want to find some way to improve on it. Or you can just return to the segment list and select another level. So now we're going to have this one done. So now I'm going to talk a bit more about the way this screen is basically made. So as you may see, I can select a bunch of lines if you wish. Technically, I cannot transition between these by changing. Technically, I cannot move them directly between lines because these are actually a bunch of text fields which are laid on each other. That is because there are some restrictions that I had to take in order to improve the way it would look graphically. Because if I was to use, for example, a text area, I could not limit the amount of text that it would contain, that a line would contain. It would scroll and would almost look kind of bad. So to that end, I ended up using a lot of CSS to edit the way the text field look to actually make them transparent. Secondly, what I want to also approach is the correction system. So basically, if you make a mistake, the program will not be able to run. It's basically the same way as an IDE would work. So for example, let me just write a bunch of garbage right here. So whenever a text field loses focus, it basically runs through every single text field in that particular node, and it'll try to find if there is an error. So for example, right here, I wrote a bunch of nothing, and it told me that this is an invalid operator because this is not one of the operators listed in this line right here. So this was quite simple to implement because you don't have that many operators. So there's a few cases that you need to handle to make sure that everything will run properly. About the added stuff?
Sure. So, well, we added we didn't want to add multiplication, functions because we found them easy. So you have to take care. You have to do everything only with addition and subtraction. So it's a bit more difficult. The original game I think has one of the levels is to do a multiplication, which is really difficult. And you can add up adds to the ACC and always adds to the ACC. And if you want to add the ACC to itself, you can do add ACC and it adds itself.
Right. So most of the levels that we've shown you so far were levels that were included in the original game. We included them because they were fairly easy, in terms of complexity, and they were a good introduction level to basically playing the most basic functions of the game. So now we'll show you the levels that we actually made, which are more computer science related, but are quite interesting in a way. So if you read the text description, it says that it reads a value from two inputs. And if both of them are 1, then it outputs 1. Otherwise, it outputs 0. So most of us have taken discrete mathematics, and you'll know that this is basically a AND logical operator. So basically, whenever you receive 2 1s, which are 2 trues, it outputs true. Otherwise, it will just output 0. So we basically mentioned the way run worked, but for example, what did it do?
Well, I can explain you the loops.
I know why it doesn't work. This is not. Because I re-downloaded your file and it was the inverted XOR and an X. XOR and AND.
Yeah. Okay, so you want to open it so I can explain the loops?
Loops? On which one?
On the 6 or 7.
Where there's no loop on those.
Yeah, this one there's
Right.
too. Okay, so we implemented the loops in different ways. So first you have to write create a label of the loop, which is like create a variable, so you can actually create variables. Here we call the variable and with 2 points. And if you call GZ, which is like when the ACC is equal to 0, here it goes to the and loop, so it creates a loop.
Now it should work properly because the XOR should be this. Both. Should work properly. Yeah. So, simple mistake on my part. We actually had a bit of communication issue. Level 7 and 8 are actually the AND operator and the AND exclusive OR operator. And so what ended up happening, we actually probably made a mistake somewhere, and so the inputs and expected outputs for the AND operator are in the level for the XOR operators and vice versa. So it still works. I just did a few modifications, so it still works. Program is saved.
We have 2 minutes.
2 minutes?
Do we have other functions?
Right, so we mentioned, I showed to you, for example, the levels. So a lot of the things that the levels can be completed fairly easily using not a lot of operators. But once you get, for example, in level 8 and 9, which are normally locked, now you get into more complicated levels. For example, reading a full sequence of values that are terminated with zeros. So it uses a lot of the sequences, for example, needing to check whenever a value is equal to 0, and a lot of the other operators which are listed here. And so the difficulty of the program quickly ramps up, and so it really helps you to perhaps think like a programmer, having to subdivide your work in certain cases which are contained by nodes.
For example, this one is like it gives you some inputs, and each sequence ends with 0, and then you have to give the minimum and the maximum of the values in those sequences. I think this is one of the numbers of the real game. Right?
Yes, this was a fairly hard problem. I'm the one who brought up the idea of making a replica of the original game, because I found that some levels were very interesting to try to implement, and this was one of the ones that took me a very long time to complete on my own time.
For example, this one you can find the solution online.
Yes.
Because I don't think I would be able to find this solution.
Right.
I guess that's pretty much it.
I guess that's it.
Okay.
Thank you.
Welcome to our presentation. I'm Jacob and this is Jonathan, and we're here to present our game called Fly Me to the Moon, which is the space traveling experience you've always dreamed of, is finally within your gravitational pull. So, today we're going to talk about the story of our game and the tools we use to make it, the design of how it works. We're going to give you a little bit of examples of the images, then we're going to give you a demonstration, and finally conclude with a final word. So the story behind our game. So while we were searching for games, we had a couple of ideas, me and Joe, that we bounced off of each other, but none that really stuck. And then one day Joe came to me and he said we should do a space experience, space simulation game, which we adapted into a simulation and a game because we thought it would be a kind of out of the ordinary project and something that not a lot of people would have thought to make. Also, our game does have an underlying story between its missions. It has 6 missions in total and a free roam mode, so you can play forever. But it does have also a little bit of a story that's explained to you throughout. It's not the biggest part of the game, of course it's the gameplay, but it is something that engages the player even more in his experience. So the tools we used were all of the tools we knew, because we really wanted to make this game from scratch. We thought that it would be a nice challenge, but also very important for us to use only the knowledge we knew, because it was kind of a challenge of us to
display our own skills and try to face the problems that we thought of with what was available to us. So we use NetBeans, which was the best IDE between this one and Eclipse because it works extremely well. We use Java, and of course it runs on any Windows computer.
Okay, so now I'm going to talk about like more of the technical aspects of our game, the design choices we made to make our game an accurate simulator of a rocket in space. So first of all, our game is based on Newtonian physics. So we're going to go through step by step what our game calculates every frame, so every update. So we get the position from the position it was before, plus the speeds divided by the number of updates per second. So this is basically this is like basic mechanic physics. You all know this, I expect. This is then the speed is calculated from the old speed plus acceleration divided by updates per second, and the acceleration is calculated is the force divided by the mass of the rocket. So this is where it gets more interesting. So what are the forces that we calculate in our game that are going to act on a rocket? And these are the three main actual forces that act on a rocket in real life, as shown in this beautiful picture. So there's thrust pushing the rocket forwards, and there's a drag and a gravity working against it. So for gravity, we use like the gravitational equation. So this is once again real physics we implemented. For drag, I actually had to go look up the drag equation, how it works and stuff. And this particular variable, the air density variable, it changes with the altitude the ship is when above a planet with an atmosphere. So we had to figure out a way to have a function that would give us the air density depending on the distance from a planet with an atmosphere. So this was a part of our design process.
And it works with the altitude and the gravity of the...
So yeah, we made like a custom way. So if we want, say, a planet with an atmosphere, we simply have to tell it to have an atmosphere, and it will calculate the proper atmosphere depending on its mass and depending on its radius. So it's all automatic. So it will enable us to create like missions really fast this way. So and finally, the engine's force is simply the engine power in Newton and times the motor power, which is something that I'm going to explain later. So now another key, really important element of our game. Well, two important elements of our game are the prediction line and the fast travel. So as shown in this picture, this is the prediction line, and this is the UI element for the fast travel. So how does the prediction line work? Well, it works with the same physics that we use to move the rocket, except that instead of moving the rocket, it only stores data in like a huge array, and in the array are contained the speed values and the position values of the rocket. So this would be like the speed. So it calculates with bigger leaps than the update than our game normally runs. So it can calculate into the future where the rocket is going to be. So it's less precise. So it uses the future position of the rocket and the future speed to then calculate another value even like further in time, and then it does that until it has like a huge array of up to like 3,000 values where the rocket is going to be in the future. And and fast travel is implemented. It's really simple. We simply added a variable that we multiply in the position and speed equations in our physics update. So that was less complicated. So multi-threading. We choose to use multiple threads for our game because it has to run a lot of calculations, lots of times per second. So we chose to make use of the full potential of modern computers and them having multiple cores. So we did multi-threading. So this is like a really simplistic graphic of how our different threads work together. So this is the update thread. It moves the rocket as I explained. This is the prediction thread. So our prediction line works in a separate thread, so it can have more computing power on its own. And finally, the JavaFX thread. So this is kind of the way the relationship. So the rocket is modified by the update, but it is also used for the prediction. There's a list of planets that simply an entity that controls all of our planets. There's future, which is the name we gave to the list of future points the rocket is going to pass through. So we had to figure out how to make all of these synchronize together and work together and not cause any like concurrent modification exceptions. So yeah, that's it for multi-threading. So now the different types of planets, and as you see, this is the flat Earth because our game is in 2 dimensions, so our Earth in the game is actually flat. It's true. But it works. It works with actual physics. So who knows? So they're the planets. Well, the planets don't have anything special. So the planets with atmosphere. This is a screenshot from the game. This is how we implemented the atmosphere. And as you can see, it all works together. The atmosphere slows down the player with drag, and it's also taken into consideration when we're doing the prediction. So you can see that the line is, if we were in space, the line would be a straight line or just a normal curve because of gravity. But now that we're in atmosphere, it's like a curve, more pronounced, and it makes you crash.
And also the atmosphere, because of the drag force, causes heat on the rocket. So that is also displayed on the. It's also displayed on the UI right there. It either goes up, and if you reach the maximum, you're gonna burn out and explode.
So moons, well, there are planets that we kind of put on rails around other planets, and they turn on them, and the way we implemented it is pretty cool. So we can have a moon orbiting a moon, etc. So asteroids are planets, but they move. So they have like a velocity and a direction. And finally, 3 other key systems that we had to implement. So the heat, Jake just talked about it. It's like when you're in an atmosphere, your rocket heats up from friction. The fuel is when you use your engine, it burns fuel. And fuel is actually connected to all of our other systems. So when you burn fuel, the mass of your rockets get smaller. So you have more acceleration for your thrust when you're thrusting, and motor power is something you can control. So if you want to have a really powerful thrust, then you set it at maximum, like it's there, or you can set it to half. So the amount of force your engine produces divided by 2.
Okay, so before we get to the GUI images, just the last 2 things that we also implemented was a zoom mechanic. Like we've already discussed in our first presentation that we had done this, but the way it works is that let's say you zoom in, it augments the radiuses of the planet so they look bigger, and it also increases their distance. So since it runs extremely fast, our game, it really looks organic, like you're zooming in and zooming out, but that's how we made it work. And also we created a saving system that, let's say you just open a game on your computer, it automatically creates like a file in your computer with the saving system so that your game can access it, so that when you come back you haven't lost all your progress. However, we chose not to explain this to the player because we don't want him to just know where it is and make himself like have all the levels available. We want him to go one by one so that he has the full experience of it.
Yeah, and one final point on the design, like on the way we checked for the quality of our physics was that we inputted the real life values for the size, the mass of the Earth, and we made a rocket that would be the same mass as the International Space Station, and we put it on the same orbit. And in our game, it worked. So it has a. So this way we verified that our physics are consistent with real life.
So for the image samples, this is what our menu screens look like. It's kind of a retro mode because we wanted to do a callback to old space game like Asteroids. So this is the credits that the player can go to when he goes into option, but we're all going to show you this in the demonstration. And this is the starting menu screen that the player sees when he opens the game. Those are examples of the mission briefs that once again you'll see. It's just a display that at the start of every mission they brief you to explain what you must do, your objectives, the keys you have to use. And there's also this that is included in the user interface. So let's say you do something and then your mission objective changes. It changes the communication system, explains to you what you must do. And it's just to show that some missions have longer briefs, like at the start to explain what you have to do. Some are just fast-paced, and the longer ones are more like, okay, explore this, like bigger steps.
It also explains the stories, the story and the missions that are related, how they're related together.
These are examples of a mission. This is our first one. Here you have the communications system that says, welcome, okay, you need to do this. You start our first mission by not being able to press on the engine key, because if the player were to try this, he would go far away from what he must do at the start, so it would make him too confused. This is the second one, that you must reach a moon that's extremely far away. For our game, we decided that at this point we'd keep our rocket the same size, or else if we kept zooming out, it wouldn't be possible to see what the rocket looked like, which would confuse the player. This is our full UI that tells you the speed of the rocket, the multiplicator. And as you can see, when you've done your first mission, you get like a little medal of Easter eggs. So these are implemented like throughout the game. You get 4 Easter eggs that you can have like towards the game. I won't tell you when you get them, except the medal I've just told you, but these ones add onto the UI. They're like little stickers for achievements. Okay, so now
we're gonna do a little demo.
Yeah.
We're having some technical difficulties. Okay.
So this is what you get at the start. A little thing that we added that was provided to us by one of our colleagues, Olivier, was the mouse cursor. We thought that it would just be a nice addition. However, during the mission, since our rocket looks like this, we revert back to the original cursor, or else it could confuse the player.
Yeah,
so
props to Olivier for the design of the rocket.
So here, let's start with our options menu. You can go to your achievements. Now, here it tells you that you have completed every mission, because for this presentation I wanted to be able to show what all the missions look like. So of course they'll all be okay. Here's our input screen that explains to the player how to do the inputs, because when I tried it with my dad, he was really confused as to how to change them and if you had to press enter and what was okay. So here, let's say you put an input that's already taken, it tells you input taken, or an input that isn't allowed, it tells you that it's incorrect. So we can go back. Here's our credits, like we've showed you, it's just who made the game. But now this is the interesting part. So here we have the mission select when you've completed the game. Before you've completed mission 6, the free roam actually isn't there. So it's kind of a surprise to our player that when he finishes, he thinks, oh no, I can't do anything anymore. But boom, you have like this nice free roam that you can come back to.
So now we're going to show you missions 4, 5, and 6, which are like the main story arc of our game. So let's jump right in. Well,
so here we have how our briefs works. It's like before you see the computer is talking to you. We thought that this was like a nice animation that the player might find it familiar, since he's probably seen it in movies before.
So yeah, well, I'm just gonna resume this quickly, but basically the Earth has sensed that there's a wormhole close to them in an asteroid field, and they send you to investigate the wormhole. So you have to find it, use it, a radar, a gravity radar.
So here, there's the return and accept buttons. If you press return, it would bring you back to the mission select. But we won't do this right now because it would have to rewrite the entire brief again, and that takes time. So we'll just accept the mission. So here, it tells you the range of your sensor, and this is how your UI works. So you can zoom out, and you see the whole asteroid field. So if we were to go here, and you fast
travel.
See now it changed color because you've kind of see it changes again. Oh, we would get
and the wormhole is an object, but it's completely black, so we can only see it when it intersects with our radar. So you're gonna see soon. It's pretty
so
cool.
the blue is really means it's really close. So here you can see that it intersects, and then when you hit it, it gives an animation that, oh, you're going through the wormhole, and then it says, oh, congratulations, so you can go back.
My time to shine.
Now this is
2 minutes.
Okay, this is our favorite mission because we thought it looked the coolest. So it says that when you've teleported from the wormhole, you're near an exploding star, and that's surrounded by an asteroid field. But the heat from the star has fried your prediction line, so you must get out before the star catches up, or it'll kill you.
So I'm just gonna do it. I might not even get it because it's pretty hard.
And as you can see, the heat is going up because the star is getting closer.
Yeah. It's kind of an indicator of how close the star is. So
faster.
This might look easy, but it's actually pretty hard.
See, and then when you crash, there's a little animation that you crashed, and then it tells you mission failed. So
well, we can go on to mission 6
Okay, yeah.
as if I had escaped the asteroid field. So mission 6, well, the story of mission 6 is that you've managed to escape, then you come back to Earth, but the wormhole, it works in both directions. So the supernova has shot asteroids through the wormhole, and now they're going back on the collision track with the Earth, so you have to destroy them. And so for this mission we have a unique mechanic of a gun, like a cannon we have added to the rocket.
this was really like a reference to the game Asteroids.
Yeah. So
you see here, it asks you, oh, please save us. And this is our planet, and these are the asteroids. If you press on T, you can see that they have a speed, like they're coming towards missions.
Yeah.
Here, that's our gun, and here the system tells you how many there are left, so that you can use
I'm gonna crush
your gun safely. Also, for this game, we wanted to make it challenging with the fuel, so that you don't have a big quantity of fuel. So if you don't use your motor smartly, you might need to go back and forth and lose a lot of fuel.
So yeah, this is the final mission. And
so here, there's always this escape button that you can leave, like whenever you like. Let's say your mom calls you and you need to eat, and you can't finish your mission.
And finally, just free roam is a scaled down version of the solar system. So
because we thought it would look cool.
So the Earth, there's Mercury here, Venus, Mars, and
the asteroid belt.
What's pretty cool also is that if you fast travel, you can see the planet's rotation on their orbits. We thought that was pretty cool.
Yeah, pretty much. But it's still like it works like the rest of our game. If you run into the sun, it won't just be like nice. So your rocket's gonna explode.
Oh.
So yeah.
And final thing, as you can see, since you've completed everything, like the little Easter eggs have added up on your UI. And if you want to escape this one, since it's not a fail, it just tells you back to the missions we go.
So yeah, that's it for our
That's it for our game.
Stop.
Hi, so today we're going to present our final project, which is a video game. So first I just want to introduce like what is our game, what is the the idea that we had why we wanted to do this game. So first, well, as you probably got right now, we did a video game because we're both gamers, and we think it was kind of fun to know how the games we play some of the games we play are made and how we could try to replicate them. So this is one of the ideas that we wanted. Also, it was a requirement to include some kind of science into this game. We could just not make a game that was just be played for fun. So we thought of a game that would be more for children and kind of to learn science or to get an interest in science. And we both really like physics, so we tried to make a game that would include as many of the aspects of physics as we could. We could, obviously not all of the aspects of physics are included because some of them are just pretty impossible to include in a game for children. So the goal of our game really is for example, I don't know if some of your teachers did this to you, but in your class, sometimes my teachers just put up a game on the screen and the game was kind of interactive, was fun, and it allowed the students to learn some of the aspects of physics or of math or things like that. And I think it was nice to do, but we inspired from these types of games, but ours is more for people just to play on their own and have fun, and at the same time try to get an interest in physics or other types of science.
Alright, so I'm going to explain the mini games. So again, we have 4 mini games. So the first one is more of a logic mini game. So you really want to exercise logic. So it's not about physics. It's a simple riddle with that includes logic, and it's basically for the player to get used to the controls and really so he can understand how the things work. So basically the player can click on the instructions button and an instruction menu will appear. There he will be able to read everything and he will be able to understand. So basically we have a balance and we have 9 black balls that we need to find the one that's heavier than the others. All right. So by using logic, well, I won't say I won't tell the trick, but you'll want to use a specific method of placing the balls on the balance in order to find the heaviest one. So the second mini game is an electric circuit. So it's the first one that includes physics, it's electricity and magnetism. In this case, it's only electricity. So we have 7 resistors that we have to place on the circuit above. If the player clicks on the instructions menu, once again he'll be able to find the instructions that will tell him exactly how many amps, exactly how many volts, and exactly and here we have the exact resistance of each resistors, and the player needs to drag them into the black boxes here to create a circuit that will allow the correct voltage and the correct amps. The third mini game, it's about mechanics. So basically there's a big cement block that weighs 160 kilograms that's blocking the door. In order to move it, you'll want to use the rope you found on the prison level and use them to lift the block using the pulleys that are provided to you. So you'll need to arrange a certain pattern of pulleys in order to divide the weight that the machine can make. No, in order to facilitate the engine to lift the weight. Yeah. And the fourth mini game, it's about optics. So basically there's a laser beam that is emitted by a laser emitting machine, and you need to orient 2 mirrors in order for the laser beam to hit a sensor that is right here. So you'll need to adjust the angles in the mirror in order to hit the sensor. So we also have 3 levels where there are turrets. These turrets fire plasma balls, which kind of hurt. So if you get hit by one of these balls, you basically die, and you have to restart the whole game. But for the purpose of the presentation, in order to show you everything, and since we might die during while we present the levels, we decided to fix something so that you don't have to start from the beginning, which will make the presentation easier. So yeah, basically turrets, they fire at different speeds, but each turret fires at a constant rate. In the first level, there's only one turret that fires really slowly, so basically you can't really die from that one. On the second turret level, there are 3 cannons. There's like one is really slow, one is a bit faster, and the third one is really like fast. And you need to dodge them once again. On the third turret level, there's 2 turrets that fire normal. They fire normal plasma balls, but 2 other cannons that fire tracking balls. So these ones will try to hit you and they will follow you. So you better run and you better be good, because if you're not, well, you die.
Okay. So now we just want to talk a bit about what were the major problems we had to go through when coding and when developing the project. So the first one was the game, like the core of the game. So what we call the main game. We had to, because we basically had to implement a way that our character could stay in the game and keep going through the levels, and you could just walk from a door to another one, and we could keep track of where he is and how this works. So if you want to explain a bit more.
Sure, yeah. Basically we have the main game where the character is, and basically each level is a pane that you add onto your main game. So when you're done with a level, the pane is cleared and there's another level that's introduced, and the character can continue. So it's pretty much that.
For the mini games, it's pretty much of the same concept. When we add a mini game, there's an object that when you click on another pane is added, and where there's the mini game. And each mini game is really different. There's no like similarity between them and the coding, so we had to do each one after the other. And for mostly it's about the coding problem was about dragging and keeping track of where all the objects were, and if you failed, how to restart it. The cannons, there are 2 animations that for how the cannons work. There's one for the bullets, because you will see later in the walkthrough of the game, but the plasma balls really move while they shoot to it, just make it a little bit nicer. And there's also another animation for how the ball moves and goes. And Charlie created a small algorithm for how the balls would track the player in the last level with cannons. Also for walking, it was not as easy as expected. It was not a big problem, but we had to change the walking algorithm because there were problems and it was not smooth enough as we thought. So that's one of the things we improved during our game. So we had to change the way we did this little algorithm.
So the softwares we used during the creation of the game, NetBeans, of course, to program everything. We used Windows because our game is pretty much played on Windows. Piscale to draw the little images, that would be like the resistors, like the circuit. And Microsoft Paint would be used for the backgrounds because you can create bigger things and it's easier. And then we used GIMP too, which allowed multiple images to be put onto each other without like the white borders.
I just forgot to mention at the beginning, but one of the other things we really wanted to do, we wanted to make all of the game on our own. Like we did not want to use images on the internet. We did not want to use any libraries. We just wanted to go from scratch and create our whole game using the programs to create our image and like only the IDE to create our code and not using any tools to help us. And even you'll see, but there were images that took quite a lot of time. Mostly the credits image at the end. And so we'll just go through.
Just go through again. So you guys were masters, so no worries.
It's dragging? Oh, it's good.
Great.
So there's also, the only thing we did not create ourselves was the music.
Oh, there's a music, by the way.
But it's the only thing we did not create ourselves because we're not musicians and we don't know at all how to create music, so we had to take that from the internet.
Why is it not showing up?
Okay. The game shows up on the computer, but it does not show on the screen.
because your screen is duplicate, not extended. So.
Oh, do I need to drag it?
Yeah.
Oh, okay. All right. Oh, that's making it hard. All right.
Yeah, that's one of the images that Jean-Luc drawn.
If you want, go on the desktop.
What?
Right click on your desktop.
Where's my desktop?
Yeah, display setting.
Display settings. All right. Display.
So.
Oh, it's on my screen.
Yeah, instead of extended, use duplicate.
Yeah. All right. I'll show
on 2. Oh, it's gonna be the same.
What did I do? Oh god. All right. I'll try to. Yeah, like this.
Go like that.
There we are. I'll just do it that way.
Yeah, he might die because it's going to be complicated. One thing before he starts the game, the commands are really easy. It's basically only the keys the arrow keys to move. There's up, down, left, and right. The player can jump, can't jump because you see it from top-down view, so you only see the head of the player. So you can only move in each direction. You can move in diagonal or however you want, and the mouse is used to click on the object to interact with any object that are in the game. So that's the only commands we needed for the game. So we again try to make it simple for children or younger players.
Alright, I'll just start the music just so you guys can hear. This is beautiful music. Can everyone hear?
Yeah. And also there's the help button right there. That's it's more of how the game was made and everything, because you don't need any information. The game is pretty self-explanatory. It's really easy to play.
Alright, so we'll start. There we are.
And so first we made a note, that's an introduction. So in every level there's a little text that explains you what to do and how you have to do it. So the walls you can go through, that's really, the two first levels already how you walk through the game, how you start just to get used with the commands. Then this is the end of the first level. So you see that you can't go through in the door. It's locked, you just can't move there. So you have to, go check what's going on there. And this is the first mini game that he explained. This is just to.
Does anyone have any idea how to do that?
You place the balls and you check.
But you can only
only use it twice.
In the instruction, it said you can only use this twice, or you fail and it just re-randomizes the balls. So you have to only make it. You can get it by just being lucky, obviously, but there's an algorithm so you can find a way so it works every time. Jake?
You put the 3 balls on each thing, and then.
Yeah. Very good. Well, I'll try that.
Wow.
Oh, it's basic.
Very nice.
Alright.
This is having a hard time with
Can I check?
You use it.
I'll use it. Alright. Left step here. What do I do?
You take those 3 balls and you put, keep one of the, take all the 3 off on the right.
Alright.
Those ones up. Then put one of the 3 on the right, then take the other one off, then use it.
It's left again.
Then
That's
that
again?
one.
Is that the good one?
Yeah.
Can't see.
Wow.
Oh, that's
You're
That's
great.
for sure good. So
That's an algorithm.
this was kind of again a warm-up level for the player to understand how the minigame works, and it's just a fun logic riddle. So now the door is unlocked, and the player has all what he needs to understand the game. And also, we could have made the game a lot harder by, let's say, just adding cannons into this level to make it a bit more challenging for the player. But since we want it to be really for children, that's why we chose not to add too much challenging features.
So basically, you have to pick up the resistors that might be useful later on. Let's see about that. So as you can see in the inventory here, we have the resistors that have been added. Wow. Okay, there's a cannon now. Now the objective is not to die. I almost did.
So that's what I was talking about, the animation for moving, the ones to make it a bit more interesting.
Oh.
What?
That's not.
Oh, the level is so dark. Why? Oh, maybe if we read here, we will know why. I can't see anything. Maybe the resistors I picked up earlier could help me restore the light. Ooh, let's check that out.
So again, no one can really calculate that right in your head, but you have like all the information. It's basically like a baby version of Kirchhoff's law. Just to you have like many values. Just we tell you all many values, and you just have to look at the resistors, which one would go where, so it matches like the right.
So everyone take out your calculators and sheets. We'll calculate the circuit.
So we know it, so we're just gonna place them where they should go, and it's only in this pattern that the circuit actually works, or else it would not work.
Are you sure about that?
So
Oh,
now,
the light is restored. Wow.
Now that the light is restored, you can keep on going. Here we just
basically picking up rope that might be useful once again. Oh wow, I
it just is at the character because it's fun and why not? So then this is the second level with cannons. It's a bit harder.
It's gonna get hard.
Yeah, and when the character dies, there's like the screen goes back and you can't move, and there's only the options
Do you want me to die or not?
or either no, sorry, last one. No. And you can either restart the game or just quit the game. And if you restart, well, normally it restarts to the beginning, but now it's going to restart to the same level.
All right.
So here you have to use
So
the
for
ropes.
this one, does anyone have any idea how to? That'll be long.
So if you know how pulleys work, each rope divides the mass. So there's a little trick. You have to skip the second one, because if you use a rope, you have a limited amount of ropes. It's told in the instructions.
Yeah.
But if you only use this pulley, well, you basically mess up because you don't have enough ropes to divide the force enough. So you have to use it this way.
All right. This game looks easy. As if you actually did calculate. So, we'll take a guess. Which door will lead us to the good one?
This one.
This one?
Just came from
This one?
That's not the right one.
Top left.
Top left?
Top left?
So you basically have to move around and try every door until you get the good one?
No.
Yes.
This one?
Yes.
Try again.
Top center.
Top left. Top left? I already tried that.
Top center. What? Top center.
Top center. Alright. It's gonna take a long time, guys. I'll just have it, alright?
Close enough.
You guys had it.
So this one is the one with where the plasma balls track the player.
Oh non, tu vas mourir.
And
don't worry, I got this. Oh shit.
So you have to loop. The trick is basically to loop around until you can find an opening from this cannon.
Alright, I'm sorry. So for the purpose, we did it so we could just start at the level behind. Which is easier.
Oh
my god. Alright guys, so normally I get it, but yeah.
We just gotta finish that until we show you the next level. So
yeah, it's not that hard. You guys will get it, I'm sure. Alright.
Well done.
There we are.
So the final level is the last field of physics that we could cover, which is optics. We thought at the beginning of trying to cover quantum mechanics, but we had no clue how to make a mini game that would include quantum mechanics. So we kind of chose other field of physics over this one. So for this one, you have to this laser here is fixed, the angle is fixed, and you have to orient the mirror here and the other smaller mirror here to you have to orient this one to hit the really small mirror there, and then to hit this target there in order to complete the game.
So the angles vary between minus 90 degrees and 90 degrees. Does anyone want to have a quick guess? Just
and any input to see. This is on this way it's minus, on this way it's positive.
36. 36.
36 is
right,
this way.
that's not gonna work. There we are.
Minus 30.
Oh, minus 33.
33?
33.
I don't know if I can
Oh,
put
yeah, you put
33 there. Alright, I'll just get this one. There we are, boom! Alright, what angle should this one be? 6.5, alright, we got it. Wow!
And when you do this, you completed the game, and that is pretty much it.
The door is unlocked, and we can go on to that conclusion, which I drew myself.
Yeah, this is one of the longest image that Sil has drawn, all of it.
Very nice.
Wow.
Yeah.
Oh, you
thank you.
Very nice.
It took me like multiple hours to do. Alright, we got it.
You can stop.
Welcome to our presentation. We're going to show our program, which is called the Cédamine Physics Toolkit, which you can probably guess is because I'm Cedric and Damien, so we're the fun masters and we like
the greatest fun masters of all time.
Okay. So what is this program? This is a set of simulation-like games, well, semi-games, that are for a few physics and mathematical phenomena. The main thing is that there's multiple different simulations, which are essentially windows that you can put the simulation in, and you open them, and then you can play in them. And currently 6 are implemented. So the structure of the program, essentially how we implemented it is that there's some functionality that is common to all of the modules that we have. So we have the class, and the main part of the program is the core, which takes responsibility of most of the background stuff that is done by the program, and every module have their own class who has the data fields that are necessary for their specific simulation, and most of them having common features, have the same features extended from their superclass, so that it depends on the module. And the modules, as I said, are each of the physics simulation. So it's like the components. It's one of the basic units. Well, it's the basic unit of our program. And for example, there is one for the circular path taken by some particles with the centripetal force. Then that's the kind of phenomenon that we're trying to show.
Also, when you click on this button, it will open the window for the module, and if you close that window, if you click on the button again, it will save the state as it was. So in order for our program to work, we knew we had to generalize certain things. We knew that each of the modules needed to be elements. That means they needed to have a position in X, a position in Y, and sometimes they needed a velocity in X and a velocity in Y. But the class elements is for the elements where the display is created with JavaFX. So we use lines. Well, we use libraries brought us by JavaFX to create shapes. And spreader elements are actually assets we draw ourselves in order to display them. But essentially they work the same. That's the default sprite we use.
Well, we don't use it.
Yeah, we don't use it that much.
So one of the most useful things that we can implement is a custom icon button. So that's one of the first things that we wanted to implement, and that's made with an image view, which when clicked deploys a new thread which keeps the time during which, after which it was clicked. So, because one of the things that we want to do is to have the functionality of double clicking and single clicking, there's one of the threads keeps the time, and when the time is over, the image view switches its display from on to from pressed to idle, and when the button is set to single click, it doesn't do that, and it directly does the action of its button. We have an inventory system in most of the modules that have deployable items, and that's essentially that the inventory contains a lot of inventory icons, which when you click the inventory toggle icon, these are popped out, and you can click them to create an element such as a spring or a circular motion body or something. Anything else?
Yeah, this is fine. Oh no, this is. So we knew that when inputting values, we had to put some restrictions. For instance, when we want to input the mass of an element, we knew that it needed to be always a positive decimal. In that case, what we do is that we add a listener to the text property of the text field receiving the value, and each time the text is changed, it will check if the text is still good. So for instance, if there's a negative value in the text field of mass, it will automatically remove the minus sign. Like it will prevent you from writing the minus sign. And but usually we generalize it so that it will remove any. There will only leave digit characters, one minus sign at the beginning, and one dot. So that's one of the first module we're going to show is charge particle path module. It simulates the path of a charged particle between plates of a capacitor. So in order to do this, we needed to create a class: electroplate, parallel plate, capacitor, and charged particle. Electroplate handles the display of the plates, and it takes into account the direction of the electric field. So for instance, in that case, if you remember our electricity class, we know that the direction is from there to there. So it will display accordingly the electric plates. And it extends by the element. Parallel capacitor is it takes the electric plate, but it also has a shape, rectangle, so it detects whether there's a particle inside or not. And it also, when you create a parallel plate capacitor, it takes into you need to input the sheet charge density of the top plate, the separation distance, that means the distance between the plate 1 and plate 2, and finally the orientation, so that you'll see what I mean by orientation. And extends the element. And charged particle handles the mass, the charge, the velocity in x, and the velocity in y of the particle. And we made it so that depending on the charge, it will display a different sign. So if it's a negative charge, it's negative. If it's positive, it's positive. And if it's a neutral charge, it's green and with an F.
So another of the modules is one to show the spring simple harmonic motion mechanism by which in which some springs in general, when they have a weight attached to them, they are extended, and by their extension, there is a repel force which pushes which pulls the mass back up, and there's an interplay between the gravitational force and the repel force of the spring, which is in such a manner that it is modeled by a sinusoidal wave. So that's why, So to model this, we have a class which is an oscillator, which takes time values from its internal clock, and which is also why it needs a separate thread, because otherwise it entirely freezes the program, because when the curious implementation of timekeeping is having the starting time and having a loop that loops nothing until the time is elapsed, which is the current time minus the start time is below the delay. Maybe I got the inequality wrong, but the principle is the same. So the oscillator is just an abstract class, so it's not really an object. It's just, an object in sense of physicality. So it takes the mathematical.
Just a second. Continue. Yep.
It generates the mathematical values of the spring's amplitude or length by the amplitude of its oscillation. So the rendering of the springs, because we don't have a huge rendering technology, we had to settle for a sawtooth representation of springs. So
So wave superposition module. Well, we didn't really limit ourselves to creating only waves, but we can also create polynomial function, and decided to make a specific case for linear one. In case you wanted to add customize the slope and the y-intercept. So how it works is that it to generate the curve, it uses a classical function which evaluates the value y at a certain point x from a value position y. Position y is the position of the x-axis toward in our plane. So it does that. It evaluates it all the way to from the left to the right, and it displays it. But one thing that's interesting with our program is that not only the fact that we can create 4 types of waves: saw wave, square wave, triangle wave, and sine wave, but we can also superpose them to create entirely new waves.
Which is the point of this module, to show that the waves add up.
And creates new shape. And you can also add up those composite functions in order to create newer ones. And to do this, we simply created an array list for composite function, that it takes all the functions and executes all of the evaluate at method for all of them.
So the circular motion module is, as I explained before, the particles that are, objects in general that have a centripetal force while they have a velocity around a certain point, such as planets and asteroids or big leaves. They have a circular path because of the interplay of forces and kinematics.
Can you go to your application, because you have only 2 minutes?
Okay. So basically, the implementation is very straightforward and intuitive. Momentum module show that the objects that are in collision will have different velocities when they exit the collision, and modeling gases by their field state. So
that means you don't lose any energy.
Okay, so let's run the program. So we made the music. Well, I made music myself. So yeah, we have
making music.
we have some button and the thing doesn't. You can adjust the volume.
Yeah, let's just go with Arabic. Well, what did I make it? So for instance, if you want to create a capacitor, you so you have a window that will display it. We put it in nanocoulombs because or else it's going to be taking very large values. Just a greater distance. We use CNAX in order to displace it in the field. So very quick, we press this play button. And now the space detects that there's a charge, and then it does a motion. And you can just clear this and what was this?
There's the inventory system which deploys and retracts the icon. I'm just going to create the default spring and get some mad stacks of weights. And we see that it's going back and forth. So yeah, it's some
wave superposition. Just going to show you real quick. We have the sign. You can also change the phase shift. That's a square wave. But now you want to say, let's take the ES. Okay. The factory is supposed to display that.
Okay. So
it's over?
yeah, since we're running out of time. Thank you.